A familiar oil reference code can point to a product family, but it cannot confirm that a replacement will suit the refrigerant, compressor architecture, operating temperature, viscosity requirement, or oil return conditions. Treating that code as approval can turn a routine purchase into a delayed commissioning, unnecessary flush, service revisit, warranty dispute, or untraceable quality investigation. Compressor oil replacement is therefore a controlled technical change, not simply a product comparison. The objective is not to prove universal interchangeability. It is to create a traceable evidence package that enables purchasing, service, and technical teams to reach the same conclusion from the same system facts. The first verification gate is system identification. Record the refrigerant, compressor model, application, operating history, and current oil reference before evaluating an alternative. This is especially important for POE oils in HFC systems, where compressor design and moisture control practices affect the risk. The second gate is viscosity and temperature. Confirm the required grade, then assess the proposed oil against actual temperature, load, and oil return conditions. Higher viscosity does not automatically provide better protection. The correct grade is application-specific, and an unsuitable choice can create operating, efficiency, or oil management problems. The third gate addresses chemical family and mixing risk. Identify the oil already in the circuit and determine whether residual oil may remain. Any requirement for a changeover procedure, flush, or residual oil assessment must be documented before filling. Gate 4 matches the evidence to the service scenario. Initial fill, scheduled maintenance, emergency replacement, and refrigerant retrofit do not carry identical risks. A service refill must clearly state what is known and unknown about the existing lubricant and maintenance history. The fifth gate preserves approval and traceability. Link the decision to the current technical data sheet, safety data sheet, certificate of analysis, compatibility statement, approval record, site log, and applicable change control information. Together, these documents establish product identity, handling requirements, application boundaries, delivered batch accountability, and the basis of the final decision. Each document has limits. A technical data sheet should identify the oil family, viscosity, relevant physical properties, application scope, and storage guidance. A safety data sheet covers hazards and handling. Neither alone proves compressor suitability. A certificate of analysis connects the delivered batch to specification limits and a traceable identifier, while a useful compatibility statement names the refrigerant, compressor scope, viscosity grade, intended use, residual oil conditions, exclusions, and a route for technical escalation. Evidence should be prioritized rather than merely accumulated. Critical evidence covers the refrigerant, compressor, viscosity, and mixing limits. A mismatch here stops approval. High-priority evidence includes the TDS, SDS, compatibility scope, and COA. Change control, packaging, storage, and supply continuity support repeat purchasing and controlled maintenance. Application cases, technical communications, and reference material add context, but they cannot override a critical incompatibility. Implementation must protect the decision after approval. The purchase order, package label, delivery note, and technical record should identify the same product family and grade. Receiving personnel should verify package integrity, quantity, available date coding, and the batch document route. Any mismatch should be isolated before the oil enters stock. POE oil should remain sealed, clean, dry, and protected from moisture and contamination according to its storage and safety guidance. Where requirements remain unclear, maintenance history is mixed, or a new supplier is being qualified, managed field validation may be necessary. Define the sample scope, observation period, operating indicators, acceptance criteria, stop conditions, and decision owner before installation. A stable temperature or absence of immediate alarms is not enough to validate every selection assumption. Finally, review the installation after the agreed operating period. Record observations, exceptions, and corrective actions. Approval may be reused only for genuinely identical system conditions. A defensible replacement rests on a continuous chain of system-specific evidence, from selection and receiving through installation and post-service review.